Hello everyone, welcome back to the channel. Today we are starting with another topic, that is HCF and LCM, and this is going to be the last topic of number system. After this we are going to start with algebra or arithmetic, and this marks the sixth topic of number system and also the end of topic number system, right? So let's start. Today we are going to learn about the HCF and LCM. So before that, just a quick recap of what we already know about the prime numbers. So this is going to be like a subtopic in this section for you to better understand the further topic. So what exactly is a prime number? We have already learned. A number is a prime number. A number is a prime number when it is only divisible by 1 and itself. So suppose I take a number 12. So asking you, is a number prime number? So you will say, yes, it is divisible by 1. It is divisible by itself, 12. But what about the other numbers? It is also divisible by 2. It is also divisible by 3. It is also divisible by 4. And it is also divisible by 6. So apart from 1 and 12, it is divisible by other number. So we'll say it is not a prime number. Similarly, to take an example of 13. So apart from 1 and 13, there is no other number in between which divides 13. Hence, it is a prime number. So this part is clear. What is a prime number? Prime number is a number which is only divisible by itself or and 1, nothing else. Let's take next part. Prime number which are less than 100. I've already told you you have to learn these 25 numbers for quick so that it is easier for you to do questions in the exam. You don't need to recall and start writing all the numbers. So these 25 numbers, the prime numbers from between 1 to 100, you need to know by heart. There is no other option. So I'm just marking it here for you to memorize it for the exam. Next part. What are co-prime numbers? Co-prime numbers are those numbers which have no common factor other than 1. Co-prime numbers are those numbers which have no other factors other than 1. So what are factors? Factors are those numbers which divide the original number. So if I say 12 and 13, so 12 or 13, let's take this example. I've already told you, since 13 is a number which is a prime number, so only number which divides 13 is 1 and 13. So the factors of 13 are 1 and 13. What about 12? So 12, rather than only 1, we have 2, 3, 4, 6 and 12. So these all numbers divide 12. So now they are asking you, are 12 and 13 co-prime? You will say yes or no. Yes. Why yes? Because you simply see here, we have only 1 which is common between 2. There is no other number which is common factor. Hence we will say yes, they are co-prime. Correct? Now let's see the example of 12 and 32. So in case of 12 and 32, we have 1, 2, 3, 4, 6 and 12. In case of 32, we know we have 1, 2, 4, then we have 8, we have 16, we have 32. Correct? So what are the common factors in these two cases? Here we have number 1, we know that's good. Number 2 is also there, number 4 is also there, and so apart from 1, there are other numbers which are common factors. So we'll say no, they are not co-prime. Correct? This part is clear. So this is example of co-prime. This is example of non-co-prime. Now another part. Can you check if a number is prime or not? So if say 123. Since 123 you don't know why, because I've told you, you just need to remember the numbers which are from 1 to 100. You need to remember all the prime numbers from 1 to 100 and not more than that. So but if they ask you what about 123, is this a prime number? I don't know how to check. Use do 123 and find the closest perfect square. Means closest perfect square is, suppose I say 11 square is 121, 12 square is 144, 13 square is 169 and so on. Correct? So this is the number we know. Correct? So what is the closest to this? 11 is closest to this or 12? So we can say 11 is the closest number to this. So yes, 11 is the closest number. Now 11 is the closest closest perfect square. Perfect square. Now this part is done. So check the divisibility by all the numbers from 1 to 11. Nothing else. You don't need to check anything after 11. Just need to check divisibility by all the numbers which are less than 11. So check the divisibility by 1. 1 is there. So just ignore 1. 1 is not counted. Check the divisibility by other numbers. Is 123 divisible by 1? Is 123 divisible by 2? No. So 2 is gone. Is 123 divisible by, yes, 3? So answer is yes. Why? Because we know the divisibility rule of 3, that is sum of digits 1 plus 2 plus 3 is equal to 6. So if this is divisible by 3, so it is also will divisible by 3. So hence from from number 1 to 11, out of all this number, I checked number 3, and since number 3 divides 123, we'll say it is not a prime, not a prime. So what is the trick here is, you don't need to check for all the numbers from 0 to 123. You just need to check the number from 0 till any closest perfect square, and then that is all. You don't need to go any further. Now let's say an example of 233. So 233, I know 15 square is 225 and 16 square is something after that. So I will pick number 15. So I just need to check 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 and 15. So only these numbers I need to check for it to check if it is a prime number. Since 233, it is not divisible by 2. By sum of digits, it is not divisible by 3, not 4, not 5, not 6. 7 is also gone. 8, you know. So just apply all the divisibility rules, you know. 8 is also gone. 9 is also gone. 10 is also gone. 11 is also gone. 12 also gone. 13. Let's check 13. 13, 103. Again gone. 14 also gone. 15 also gone. So it is not divisible by any of the number till 15. Hence we will say it is, yes, it is a prime. Correct? This is done. So this is how you check if a number is prime or not. Also, there is another trick of uh, a prime number, or a property of a prime number. See, if a number is a prime number, it will also always lie. So you know, so multiples of 6. So what are multiple of 6? 6, 12. 6, 12, 18, 24. What else? 30 and so on. This is just a property of a prime number you need to know. So it will be like easier for you to identify without even doing this prime number or not division check. Why? How? If a number is a prime number, it will always be either 1 less than a multiple of 6 or 1 greater. So I will just note down this number. What is less than 5, 7, 11, 13, 17, 19, 23, 25 and so on. So prime number, if a number is a prime number, it will always be 1 less or 1 more than a multiple of 6. So it will always be, it will always be 1 less or 1 more. There is no other number. So if it is not 1 less or 1 more than a closest multiple of 6, it will not be a prime number. So as I've already told you, 123. So 123, what is the closest multiple of 6? So the closest multiple of 6 is 120, we know. So what is 1 less than 120? 119 or 121. What is the next closest multiple of 6? That is 126. So 125 or 127. See, again I'm telling you, if a number is a prime number, it has to be 1 less or 1 greater than the closest multiple. But the opposite is not true. If a number is 1 less or 1 more than the multiple of 6, it is not a guarantee it's a prime number. Like 125 is not a prime number. But if a number is a prime number, it can either only be one of these numbers. Since 123 is not 1 less or 1 more than closest multiple of 6, so we'll say this is surely not a prime number. 233. What is the closest prime? What is the closest? What do we say? What is the closest multiple of 6? We know that 234, I think. 234. 234 is yes, 234 is a multiple of 6. So what is less than this? 233 or 235. So we know that either 233 or 235 could be a prime number, could be. There is no guarantee because 235 is not a prime number. But if it is one of these, there are chances that it is a prime number. So if 233 lying here, we say there are good chances it is a prime number. Then we'll use this prime number or not method to check if it is a prime number. Correct? So again repeating, how do we check? A prime number always is one less or one greater than a closest multiple of 6. Now, coming to the next part of the main topic of this, that is HCF. What exactly is HCF? Suppose there are two numbers given to you, correct? What are the factors of it? Factors are those numbers. What are factors? Let's break it down. What are factors of number? A factor of a number is a number which divides that number. So, in case of 12, what are the numbers? 1 and 12 are two numbers which are surely divisible, which divide 12. What are the other number? 2, 3, and what else? 6, 2, 3, 4 and 6, sorry. 2, 3, 4 and 6. I think this is correct. So, 2, 3, 4 and 6 are the number which divide 12. Correct? What about 15? 1, 3, 5 and 15. These are the two numbers. Correct? Now, what is the highest common factor? We know one. We know. Okay, continuing with this part, we have already listed down all the factors of 12 and 15. Now the second part is, we know factor part is done. Now we know we need to check what are the common factors. So common factors, I will just mark it down. This is common factors. This is another common factor, and that's it. So only 1 and 3 are the common factor. Now the third part is, what is the highest common factor? So the highest common factor is 3, correct? Between 1 and 3, 3 is the highest common factor. So the HCF of 12 and 15 is, what is the highest common factor? That is 3. This part is clear? Now, there's another way of doing it. Another way of doing it is, how do you calculate the common factor of 12 and 15? The another way is, should I just remove this part? See, we know that 33 is the highest common factor of the 12 and 15. So I will just write it as 3. How do you calculate 12 and 15 highest common factor? You put in the bigger number of 2, that is 15. So first thing, this method will only be applicable in case of when there are we have to find an HCF of two numbers. More than 3, I will not recommend this method. So only when two numbers are there, that is like 12 and 15, you use this method. Keep a bigger number in between, like 15, and put the smaller number here. So divide it, 12, 15. So I will have 12 ones are 12. So I'm left with 3. Correct? Now this part is done. Now bring this part to the make this as a dividend. How? Keep 3 out and 12, write 12 here. So this 12 will go here. 12 is here. Now do the division again. 3 4s are 12, and I'm left with nothing. So what was the last number which divides, or last number in the series? 12 is where we started. 3 is where we was the last number which we divided it. So 3 is the highest common factor. This is a little tricky method. I would always suggest use the prime factorization or the other method. This method might comes in handy, might not, but the factorization method is the sure shot method of solving such question, right? Correct? So as we have seen that in case of 12 and 15, we did the factors, checked all the factors, then we saw the highest common factor. And what was the division method? I just simply put in 15, 12 here, 12 ones are 12, I'm left with 3, bring 12 in the inside of the next division, so 3 4s are 12. Since the division stops here, so whatever was the last number here, whatever we divided it by, that becomes the HCF, correct? This part is clear? Now moving on. LCM. How do we calculate the LCM? So what is the least common multiple, correct? So least common multiple, first thing is you need to understand what a multiple is. So 12 and 15, what are the multiples of 12? So multiple of 12 are 12, 24. What is the next number? 36, 48, 60, 72, 84 and so on. What are the multiple of 15? 15. What is the next number? 15, 15, 30, 45, 60, 75, 90 and so on. So this way you write all the multiples. Then what is the second part? You check what are the common multiples between this. So the common multiple till now I see is 60, 60. Then you will also have a 120 here, 120 here. So 120 will be another multiple. So list down all the common multiple. Third pass, lowest common multiple. You don't go for the highest one. You see what is the lowest common multiple between these two numbers, and that will be the LCM. So LCM is lowest common multiple for 12 and 15, and that the answer of LCM of 12 and 15 is, what is the LCM? That is 60. Correct. Now, I've given you a method for HCF. I've given you a method of LCM. Now, I'm going to tell you about the prime factorial method, and this is the easiest and the best way of finding HCF and LCM. Right? How to do it? Let's start using the prime factors. 72 to 88. I've already told you in the last video how to do a prime factorization of a number. Right? Suppose it is 72. I can write it like this: 12 6 is 72. Correct? So this can be written as 6 into 2 into 6 into 2. Correct? Only means 6 into 2. This is 3 into 2 into 2 into 3 into 2. So this becomes 2 raised to by 3 into 3 square. Correct? So 72 could be written like 2 raised to by 3 into 3 raised to by 2. Am I clear? Now, what will be the prime factorization or prime factorization of 288 to 288? How do prime factorization 288? That is 2 into 144, or you can write it as 2 into 12 into 12, or you can write it as 2 into 3 into 4 into 3 into 4, or you can write it like 2 into 3 into 2 square into 3 into 2 square. You can write it like 2 raised to the 5 into 3 raised to the square. 2 raised to the 5 into 3 raised to the square. Correct? This I am just removing it. Now coming to the main part. How to get HCF and LCM using prime factorization method. I am just going to do both here. Next slide, I have written it for the LCM separately, but I am going to do it both at the same table for you to have a better understanding. So now, since first part is prime factorization done, now the second part is just simply write all the prime factors. Means all the prime factors without any power. 2 into 3 and 2 into 3. Correct? Till now, I have not written any power of it. I have simply noted down all the prime factors. Means since it has 2, 3, 2, 3, I have just noted it down here. 2 into 3. But that's it. Now, if it has been like 2 into 3 and 5, I would have written 5. But for now, just note down all the prime factors which are there. If suppose there was a number like 5 raised to power 1. So let's take it this way. Suppose this have been 5. This would have been 5. So simply written 5 here, right? But since we are not dealing with 5 here, I'm just removing it here from here. So 2 into 3. Now, what are the powers that would go? In case of HCF, look for the lowest power. In case of HCF, look for the lowest power. In case of LCM, this could sound little opposite of what the LCM or HCF says, but go for the lowest power in case of HCF and go for the highest power in case of LCM. How do we go for the lowest power in case of HCF? What is the lowest power of 2? 3, between 3 and 5, what is lowest power? Write 3 here. Correct? Now, in the second part, what is the lowest power of 3? So, the powers are 2 and 2. So, what is lowest of 2 and 2? That is 2. So, this comes here. So, if I see this is 8 into 9, 72. 72 is the highest common factor between these two numbers. Correct? Now, let's say LCM. In case of LCM, take the highest power. Between 3 and 5, what is the highest power? That is 5. For 3, the highest power is 2 again. So this will become 2, 4, 4, 6, 32 into 9, 18, 1, 288. So 288 is the LCM between these two numbers, and this is the HCF. Is it clear? Any doubt? So the simply what do we do here is we do the opposite. We do the opposite of what LCM says. Means when they say, so just remember this trick, when it is LCM, then if it is lowest common multiple, go for the highest power. When it is the highest common factor, then go for the lowest power of the factor. Correct? So this one we have already done. So 72 and 288. So what was the 2 raised to power 3 into 3 square, and we have 2 raised to power 5 into 3 square. Correct? Now just for the ease, I'm thinking of to explain it even further. Suppose the second number would have been like this into 5. So this would have the factorization would have looked like this: 2 raised to power 3 into 3 raised to power square and 2 5 3 square into 5. Correct? This is just another example. So HCF and LCM. What has changed now? I have told you, note down all the factors: 2 into 3 into 5, and here also 2 into 3 into 5. So for the HCF, go for the lowest power. So for the power of 2, between 5 and 3, what is lowest? 3. So for the power of 3, what is the lowest? That is 2. For the power of 5, here we have a 5 but with a 0 power. Remember, right? 5 raised to power 0 is 0. Sorry, 5 raised to power 0 is 1. So we can write it like 5 raised to power 0. Now, what is the lowest power of 5? That is 0. So the HCF is 2 raised to power 3 into 3 raised to power square. 8 nines are, that is 72. Correct? But for the LCM, look for the highest power. Highest power 2 is 5. Highest power 3 is 2. And highest power of 5 is 1. So we have 32 into 9 into 5. Correct? So whatever is the answer, that is the LCM for you. This is how you calculate the HCF and LCM using the prime factorization method. Correct? Now, in case of factorization fractions, how do we calculate HCF and LCM? Till now we have learned the method like 24 and 32. We do HCF and LCM using prime factorization method. But in case of fractions, remember this formula. HCF of a fraction is HCF of all the numbers in numerator divided by just opposite LCM on denominator. In case of LCM, you do this is wrong. Sorry for this. And whenever there is a LCM of fraction, you do LCM of numerator divided by HCF of denominator. Please note this down that this is a typo here. So if I say HCF of a fraction, you do HCF of the numerator divided by the opposite in the denominator. LCM means LCM in the numerator divided by the opposite in the numerator. Correct? Now, this part is clear. Let's see and let's apply this in the next example. Suppose 4 by 11, 3 by 5 and 6 by 5 are the three numbers. So to calculate HCF, you need HCF of numerator divided by LCM of denominator. So you have HCF of numerator, that is 4, 3, 6, and LCM of denominator, that is 11, 5, 5. You do the math and you will get the answer. And in case of LCM, LCM of numerator divided by HCF of denominator. So LCM of numerator means LCM of 4, 3 and 6, and LCM of denominator, sorry, HCF. HCF of denominator, that is 11, 5, 5, and you will get the answer. Whatever the answer you have got, you will get the answer in the fraction form. Correct? Now moving on to the last part. Here what you see is the previous year questions asked from HCF LCM. They have not directly said find me the HCF or LCM of it. They have simply given you a question and now you have to first interpret it is an HCF or LCM question, then second part solving it. What is the greatest length such that these are integral multiple of x, right? So x is a number, correct? X is a number which is multiplied by some part x into a. It gives you 3 1 by 2, or that x same is multiplied by b. It gives you 8 3 by 4. They need to know the highest common number which when divided by something gives this number. Is this not HCF? HCF, going by the definition, HCF is a factor of a number. Suppose 3 1 by 2 and 8 3 by 4 are the two numbers. It would be having some factors. Correct? Factors means which divide these numbers. So we need to find the highest of such factors, greatest of such factors, which divides these two numbers. So just read the statement again. What is the greatest length x such that these are integral multiple of x? Means x is a number which when multiply with some a and b gives 3 1 by 2 and 8 3 by 4. Give me the highest such number. So that means x is a factor, x is also a common factor, and we have to find the greatest of the common factor. So we have to find the HCF. So we have to find the HCF of 3 1 by 2 comma 8 3 by 4. Correct? So now the HCF is so 3 1 by 2. How do we change it to normal fraction? Multiply this, then add this. 3 into, okay, so how do we change this fraction? So 3 1 by 2, multiply 3 by 2 and add the one part. So 3 into 2 plus 1, that is 7 by 2. So this changes to 7 by 2. How about 8 3 by 4? 8 3 by 4 again. 8 into 4 plus 3 divided by the same denominator. 8 for the 32 plus 3, 35 by 4. 35 by 4. Correct? Now, how we have 7 by 2 and 35 by 4. How do we calculate it? HCF of 7 and 35 and divided by LCM of 2 and 4. So you will see that is 7 by 4. That is the answer. So just check A, B, C, D, which is the closest to all. The answer will be 1 3 by 4. If you want to learn about the mixed fraction is like this: 1 3 by 4. How to convert into the normal fraction, that is 4 into 1 plus 3 by 4, that is 7 by 4. You just let me know in the comments. I will make a separate video to make you understand about the mixed fraction. Correct? So I hope this part is clear, how to calculate the HCF and LCM. So for now we have completed this part on HCF and LCM, and also this marks the end of number system. Please go through the video again if you have not understand any specific topic, and please don't forget to like and share this video and share it with all your friends you think are going to benefit from this course. So we'll try to complete this quant section of CSAT in like 1 or 2 months, and you will have an ample time with you to solve the previous year question. So till then, see you in the next video, mostly on arithmetic or algebra we'll see. Until then, best of luck for your preparation, and please keep working hard. Thank you.